Suppose A and B are both n by n matrices. Is it true in general that the determinant of A plus B is equal to the determinant of A plus the determinant of B? Well, let's see. My initial guess is, why don't we try and think of examples / counterexamples that may try and trick this formula, which would give us indication that it's not true. So why don't we start with the simplest possible 2 by 2 matrix, the 2 by 2 identity. Its determinant is 1. And then why don't we look at the result of swapping the rows and columns, or swapping the two columns rather. So we have 0, 1, 1, 0. What is this thing's determinant? 0 minus 1, which is negative 1. And so the question is, when I add these two matrices, what is their determinant? And is it equal to 0? Let's try it. So if I call this A, call this B, A plus B is going to be a matrix of all ones. And its determinant is 1 times 1 minus 1 times 1, which is 0. Which indeed is the determinant of the first one plus the second one. So it seems like in this example, it works. That's not enough to conclude whether or not this is true. So why don't we try another example? Why don't I do, let's see, something that's not the identity matrix or super related to it here. Like, why don't I do a 1, 2, 3, 4 here? Okay, this is the same matrix we saw in an earlier example. This thing's determinant is still 1. This determinant is still minus 2, which we got from 4 minus 6. Now the question is, when we add these two matrices, is its determinant minus 1? Well, let's see. What is A plus B? 2, 3, 2, 5. And what is the determinant here? 10 minus 6, which is 4, which is not 1 minus 2. So in general, it's not true that adding two matrices makes a matrix whose determinant is the sum of the original two determinants. So in general, this is not